Hello, this is Paul from Foresight Tech. In this lecture, I will going to introduce trig substitution for another type of integral, which is square root of x squared minus a squared. The last type we did is a square root of a squared minus x squared. We use a times x equals a times sine theta, right? So, but this time is different. However, all the basic idea is very similar. Can look at the summary. If we have this type of integrand, how to do substitution? And the traditional suggestion is going to this. And this is the most popular one. Okay, so we do x equals a times secant theta. And whereas theta, whereas the domain for theta, so we suggested it before, right? It's important. Okay, theta is between 0 to power 2 and or pi to 3 pi over 2, which is a Q1 conjugate 1 or Q3, Q1 or Q3, the basic circle. And then identity, we need to use the secant square minus 1 equals, this is the Pythagorean, right? Okay, and then I want to look at it first. Why this substitution for x is consistent for all the x in the integrand. So first, for this integrand, the expression under the square root should be greater than or equal 0. After you solve, you get x either greater than a or less than negative a. Okay. However, we look at our substitution. If I do the secant substitute, we draw the graph. You know how to draw the graph. We learned this from trigonometry. First, we draw sine and then flip, right? So we get this. Okay, we look at it. And if we choose theta belongs to Q1, this is Q1, 0 to power 2, or Q3, pi to 3 power 2, pi to 3 power 2. Can I look at the graph? This graph goes up into infinity, which means what? Greater than or equal a. See, definitely. And this part, the second part, is goes down to negative infinity, which means less than negative a. Okay, so this is very good. I mean, they are definitely consistent. So be sure remember what is the domain for theta. So another step. So to do this substitution, use this integral. We can simplify. So look at it. So this is the beginning. Right, complicated. We substitute this, we get this, and then a square factored out. Secant square minus 1 is tangent square. That's a Pythagorean identity. And then take this square all out, which is a times tangent. Why is not a negative? Because what is the domain? Q1 or Q3, right? In Q1, in quadrant 1 or quadrant 3, tangent is always positive. Always positive means this is positive value already, okay, because the original a is positive. A positive tangent, this is a positive value. Don't put the negative. And then later we need to go from the beginning to the end. I only show you one example, okay. So this time, look at it. How to get this? As a normal way, okay. This is a normal way. What do we need to do substitution for x equals a is what, if you think about this term. So square root of x squared minus a squared. See, what is a? A equals 2 this term, right? Okay, remember that. So now we're going to do substitution. So we substitute. So I need to go down a little bit. The sunshine is too strong. Wait a little. So I'll put it here. Can you see? Please wait me a second. Okay. I will go back now. Okay. Now it's better. So can we look back? Do substitution is this, right? Is x equals a is 2 times secant theta. Okay, theta substitution we need. Whereas the domain for theta. Theta is greater than 0, less than pi over 2. Keep in mind that theta cannot be 90 degree, and you look at the last figure, right? Because in secant theta, theta cannot be 90 degree, okay? Or another part is theta greater than pi less than 3 pi over 2. Also cannot be 270 degree. Okay, the same. Now I just find the dx first. Sorry, and then we need what is dx, right? Dx take a derivative is 2 times secant theta times tangent theta d theta. Okay, what is simplified? What is the integrand after simplify? We already did in the last page. In the next, the previous page is what? Is a times tangent theta. A is 2 tangent at theta. Good. So we do need this to simplify. So now I just going to get the original. Square root x square minus 4 over x square dx. This is the original integration. Now what do we have? After we plug in is the top is 2 tangent theta, right? The bottom x is there, which is 2 secant theta square, and then times dx is here, 2 times secant theta times tangent theta and d theta. Look, it's complicated, but you don't need to worry, because the last the previous example we showed, after we simplify, you will get very simple. Okay, what do we get? We will get this. We will get a tangent theta over 2 times we don't have a 2 now. So because it is 4, we cancel, right? So we do have only 1 secant theta, and now is d theta. This is very simple now. But how to do this integration? We don't have a type, right? Remember, we don't have, but we can do this, okay? And the one way is going to change everything to sine and the cosine. You can find the method. Another way, I will going to use the Pythagorean, okay, to the top. Can you see the top? The numerator, I can use the Pythagorean. See what do we have later. Okay, let's see. Okay. And we use Pythagorean. Tangent theta equals secant square minus 1. This is the Pythagorean, right? I can plug this in and to manipulate the integrand. See what kind of integrand I will get. I will get this simple one. So this over secant goes to secant theta. 1 over secant goes to cosine, right? So minus cosine theta. Can you see? You can imagine how simple now. Why is it simple? Because the first, these we already know, right? And these we do have a result from 7.2 when we do substitution method. So we're going to, when we do trig, okay, that integral of a trig 7.2. Okay, so we do use kind of method, right? If we go back, you have what do we have? I mean, if I show you, you're going to find this is known from 7.2. I did show you example before. That's a very famous example. I have famous results. I put the results here is Ln. Okay, absolute value secant theta plus tangent theta. Now you should remember little, right? And then minus this and the derivative is sine. We have to have the formula. Then plus c. Don't stop here. Okay, so we need to do what? we need to do back substitution. Now it's the same. What do we have for secant, for tangent, everything, or even for sine? See, okay. So we go into the original substitution, and then draw a right triangle, right? Okay, draw a right triangle up here. So x equals 2 secant theta, and it is over secant first. Secant theta equals x over 2. Now I can draw a right triangle. I put the theta here. See, secant is what? Is the hypotenuse over opposite over adjacent. Sorry, the hypotenuse I put it here. Over adjacent I put it adjacent to here. Now you know I use the basic Pythagorean. I can solve this side. This side should be x squared minus 4, right? Good. And now we have everything. Okay, use the right triangle definition. Right triangle definition, if I put there, equals what? Now equals this ln. Let's see. Absolute value secant goes to x over 2. Okay, and what this tangent? Tangent is the opposite of adjacent. Okay, this fraction opposite x squared minus 4 over adjacent 2. Then what is sine? Sine is opposite over hypotenuse. Opposite x squared minus 4 over hypotenuse, and then plus c. Okay, you can stop at here, or you can go on again to simplify a little bit. So keep in mind that I will going to simplify this a little. Simplify. Why? Because we put it together is quotient for the ln, the logarithm. We have a quotient rule, right? Okay, you can do this. You can use the quotient rule to simplify a little of logarithm. And then, of course, the first step you need to compound the fraction. Okay, after the compound the fraction, you use the quotient there, and means the ln at the first minus ln at the bottom, right? So which is ln. The numerator is x plus x squared plus 4 minus, right? Minus ln at the bottom, which is 2, and then minus that. Minus square root of x squared minus 4 over x plus c. Okay, don't stop. Why? Exactly now we can merge these constant term. This is any constant term. Put them together is what we can do. This, okay. Put the negative ln 2 plus c equal negative. So that's all the constant, right? Okay. And now we can get the final one is the simplest. X squared plus 4 absolute value minus this term x squared minus 4 over x, and merge this term, two terms we already, okay, convert the negative. Merge these two terms as c1. C1 is all the constant, okay, and it's better to distinguish that c and this c, okay. Yeah, that's all. Thank you.